This is Quadrature Amplitude Modulation designed in Simulink MATLAB. First of all, let us see all the parameter and function of each block. First, random integer generator. For parameter, set size is set to 16 because we are using 16 QAM. And source of initial seed is set to parameter, initial seed set to 37, sample time is 1, sample per frame is 100, output data type is double, and we simulate using interpreted execution. The next one is rectangular Qam modulator baseband. For 16, we set it M array number to 16. And the input number we set it to integer. Constellation ordering is set to gray. Normalization method is average power, and the average power reference to 1 ohm. We set to 1. The phase offset is in radian set to 0. Next is Awg Antenna. Awg Antenna is a white Gaussian noise to the input signal. The input signal can be real or complex. It puts a noise in this design to be demodulated for the error rate calculation. Initial seed we put it 67, and signal to the noise ratio is set for mod, and the signal to noise ratio decibel is set to -10. Input signal power reference to 1 ohm. And then the rectangular Qam demodulator baseband. Rectangular Qam demodulator baseband. We set the M array number to 16. Output type integer. Constellation ordering is gray, and normalization method is average power, and average power reference to 1 ohm. Put 1. First offset is 0. And for the constellation diagram, parameter. What are the function for this constellation diagram? Is to see the output data from the rectangular Qam modulator baseband, and after it goes through the noise channel. Error rate calculation is to compute the error rate of the received data by comparing it to a delay version of transmitted data. For the received delay, we set it to 0, completion delay is 0. Completion mode is entire frame, output data is workspace, variable name is error back. And now let's run it. The constellation diagram over here is a diagram shows after the Qam modulator baseband. This is the the trajectory of each dot. And here is after the noise channel. The dot is scattered around, and this is the trajectory of the noise. Okay.
The method of integrating two amplitude modulation signals into a signal channel is known as QAM, Quadrature Amplitude Modulation. QAM is combined with pulse AM in wireless applications. The QAM process in MATLAB. First, we use the audio read file by recording a sound as our medium to be delivered. After that, this formula is added to calculate the step size, where max value minus mean value divided by 12. And we use the Qam mode to complete the quadratic amplitude modulation signal. After the coding in the MATLAB command has been run, we got that this is the original audio signal, which is the medium we use to transfer the audio. And this is the quantized audio signal. This is the combination of the audio signal carrier. This is the Qam scaling, we call it as the constellation diagram. And this is the Qam modulation signal, the combination of modulation signal, which we call it as eye diagram. And this is the delivered audio, which is received at the end by the users through wireless communication. So you can see the received audio and the original audio is similar.
The main advantage of QAM modulation version is the effective use of bandwidth. This is because QAM has a greater number of bits per carrier. For example, 16 QAM maps 4 bits per carrier, 64 QAM maps 6 bits per carrier, and 256 QAM maps 8 bits per carrier, and so on. For the disadvantages of QAM, QAM modulation is more susceptible to noise. Because of this, QAM receivers are more complex than other types of modulation receivers. The QAM use the amplitude of the signals to represent binary data, so it needs to maintain linearity, so a more power-consuming linear amplifier is needed. Quadrature amplitude modulation application. The application of QAM are mostly observed in radio communication and data delivery application system. QAM technique has wide application in the radio communication field. Due to the increment of the data rate, there is the chance of noise increment, but this QAM technique is not affected by noise interference. Hence, there is an easy mode of signal transmission can be possible with this QAM. QAM has wide application in transmitting digital signals like digital cable television and internet service. Wireless device technology quadrature amplitude modulation is preferred in cellular technology.